Hey, it's Joe Walsman, CEO and Master Electrician of Jefferson Electric. Today is part 2 of installing these ice cream sandwiches in that beautiful panel behind me. We've got the rich interior, but the simple, elegant exterior, the most advanced breakers on the market. Let's rock this out like smooth jazz. Here we go. So, in part 1 this morning, we went from this to where we're going here on part 2, which is that. Leviton has made an elegant, beautiful load center. 115 years in business, only 4 presidents, still privately held, 6,000 employees. This thing is a work of art, the most advanced breakers on the market. This is a smart, capable panel, currently in the dumb condition. But to elevate the intelligence, it requires a $300 hub, and then every breaker that's replaced, toolless replacement, once you have the cover off, toolless replacement of the breaker. Every smart breaker goes in. They come in all configurations, right? AFCI, GFCI, combo, single pole, 2 pole, 15 amp, 100 amp, you name it. And every breaker that gets replaced becomes a smart breaker, communicates through the hub, is eligible for over-the-air updates, such as AFCI breakers to prevent nuisance trips, and also, of course, remote monitoring. So if you've got critical loads, freezer, pool equipment, things you don't want it going bad, you can see the condition, call your neighbor, have something troubleshooted while you're out of town. That's truly an advantage. But for only a couple extra bucks, we're going to start with something beautiful. And then for only $300 more, we're going to go to something beautiful and smart. Woo! That was barely right there. And now it's not. We got to cut this up, get it as high as possible so those main service conductors will reach to the new main breaker, because there's more space in the top of the panel. So getting it higher is going to be helpful while still allowing us to work on it. So you've got a little bit, right? We can cut off here before we enter the curve, and the fitting will no longer fit on there. So if I'm looking at this, I'm going to give my best judgment here. And I think that's as high as we can go right there. And I still think we'll have 3/4 inch inside the fitting before it malforms. Yeah, this is Bruce's bandsaw. We different guys will mark their tools with different colors of tape so we can quickly spot them, because we've got a ton of Milwaukee, ton of DeWalt, all that. So let's just cut this. Get one shot. By the way, this bandsaw could cut through the Titanic, I believe. It's pretty big, but bigger than my little bandsaw micro. What do they call it?
Baby.
Baby. Atomic. The atomic with the 1.5-inch mouth. All right. Fresh blade?
Brand new.
Brand new.
Used it, cut that.
Bandsaw leans back at 45-degree angle. Just keep your eyes on the blade. Make that thing straight. Almost couldn't get it in there. All right, and here's our half-round file. Clean that up. Full seat, want to be as high as possible. All right, this is trial fit. Bruce, here comes the first. All right, keep pulling, 4 or 5 more inches. Let me help you out a little bit more. Ready, set, go. One more time. Yep, got him. Almost there. That's good. We've got a little bit more, but we'll save that till the end. All right, here comes the last one. It's going to be a bugger. Nice and easy. All right, it's going to come in slimy. What's that? Oh, really? Good. Had time to run to the second floor to use the restroom. Didn't realize I was being so slow. Oh, okay. Time to bear down. Oh, steel toe tap dance. Perfect. Let's bring it home together. Got 14 inches. Ready, set, go. Ready, set, go. Ready, set, go. All right, ready, set, go. It's just darn tight. 5 more inches. Ready? Yep, you got it. A little bit more. Ready, set, go. Ready, set. All right, a little bit more on the other one. That's it. You got him, Bruce. Well done. All right, that's gonna work. We've measured the length of our wire. As expected, it will reach. Now, coming down from the shoulder of the fitting, right there, I'm 1 3/4 to the center of my strut and 54 to the bottom, right there. So we're gonna mount 2 pieces of strut. This is coming in center, so I'm gonna measure off the wall, and I'm gonna make sure my strut is relatively lined up. It's actually shorter than the panel is wide, so it'll be hidden behind the panel, solidly mounted. It'll look really nice. I do not have a mortar patch kit, but I do have duct seal. So what I'm gonna do is I'm gonna prevent at least air infiltration. Hit those holes behind the panel. That will not be tremendously accessible at a later date. Hopefully that slows down bugs, rodents, air infiltration, energy loss. So as part of the advantage of having these standoffs is the strut that we're gonna mount is we don't have to worry about the imperfections of the wall because we're gonna have 2 uniform mounting planes. That is gonna render everything else, like this big lump right here, it's gonna render it irrelevant. We're just gonna go right over the top of that. And then if you can tell on the camera, there are a ton of imperfections. I mean, these blocks are varying by 3/8 of an inch, so that's quite a bit. It's nice, the holes in the unistrut, super strut, it's every 2 inches. So you don't have to measure anything. You know what 1 inch is, you know what 2 inches. Yeah, so that helps. See how I just mark the whole hole? So I'll just be in the center of that, and I'll have latitude to level it up, get that dialed in. Let's put 3 anchors in each. Are you planning on 3 in each, Bruce? Do we have 6 Tapcons?
I was doing 2 in each.
Do we have enough for? Okay, we'll see how it grabs. I'll add another one if we need to. That was a nice grab. Let's snug this up. That's a nice grab. Well, I'm way out of level now. Loosen that up one more time. Oh, it's the size of the washer that did that. All right, let's get that refrigerator on the wall.
I'll just stand it on my foot.
I think we're prepped.
Get it over here.
I think I got the hardware ready. Yeah.
And then
I'm gonna let you just keep lifting. We'll consider whether that ground bar lives there best once we start getting these things in. Okay, now it's time. I'm gonna pull it out intentionally.
Okay.
Slide that spring nut up to where I think it needs to be, give or take. Okay, we're there. I see it. I'm gonna go ahead and get this one locking it first. They did provide. Uh-oh. Help me hold it up. Okay.
Okay, bushing
Now the tedious.
or the wash or lock.
This actually might be less tedious than pulling it apart. That was kind of crazy. How long did we spend pulling that apart?
It was a few hours.
Call
a
it-
couple at least, I think, right?
Almost 4 hours to get everything identified, laid out, pulled apart. 3.5?
We really
That's
didn't
nuts.
stop much. You know?
That's
really,
nuts.
We didn't stop to do hardly any videos then.
That is nuts.
That was that was.
Do we have a bond wire for that? Like any scrap we pulled out?
Is that too short?
We need a number 4 copper.
Number.
This video brought to you by the nice ones from Southwire.
Someone tried cutting that nail or a screw one time. Yeah. But it still cuts
A
good.
nail or a screw. That's pretty dirty.
How to thread a bolt.
Is that what this is? A bolt? There we go.
Oh, he's there.
Okay, so there's actually not a
Flathead hammer.
bonding lug on this. Is it? There's probably one in my stuff box. This video is brought to you by Southwire. Southwire has been kind enough to send us tools, and I want to thank them for bringing us all content and helping things move forward. That's a nice pair of cutters. No, don't cut anything but copper and aluminum, nothing but wire. But they'll cut nothing but wire all day long for about 15 years. Wires in your face, a big disgrace, losing your tools all over the place. All right, let's get this thing landed. This is just a tedious job. It'd be about 4.5 hours of just carefully taking each one of these, looking for signs of trouble. Hard to get wire that's already a little kinky and get it all straightened out. It's not gonna look like a brand new laced in panel, right? One, we've got multiple kinds of wire here. Romex, MC, BX, THHN, various generations of Romex. And it's already been all kinked and squirreled up. We're gonna get it over, bring it down. We're not gonna over tighten the clamps. That's a death wish because you'll actually compress the conductors and it can be a high resistance short or a dead short right there. And that can be hard to troubleshoot. Trip the breaker and you're trying to figure out what's wrong. So 1/4 inch jacket inside the connector will terminate everything uniformly. Then we've got 2 more 13 terminal ground bars that we get to decide where to put in here. And we'll let that develop a little bit before we make that decision. And then again, all neutrals and hots will be terminated at the breakers. There's a water pipe up here that's not in service. Oh, take it apart at the union. That's where the bonding occurred. It was to this water line. And that is no longer a thing because it's been disconnected over there and PEXed. So I'm not gonna have nearly as much fight. Little demo work. It's really helpful in line of being an electrician to just have a little bit of this and that knowledge, whatever it is, a little bit of general construction knowledge. Really helps. So one of the goals we have at Jefferson Electric is to be the first company that I'm aware of anywhere to have $1 million truck. What do I mean by that? That means that one service vehicle, one truck turns over a gross $1 million of cash for the business in 1 year's time. They may sound ridiculous to you, but that is the goal. And so we're driving hard to equip ourselves to be able to achieve that goal. That is an everything all-in goal. That's permits as a profit center, not a cost center. That's the right tooling, that's the right mindset, that's a keen awareness of the code because code sells. Right? Code is all about fire and safety, and if you can quote or at least paraphrase the code to the customer, sometimes dropping in a code reference as you're able, depending on the technical acumen of your customer. Like if you're talking to an architect, you reference code with pretty kind of code language in there. They'll respect that because architects, engineers, people like that, they live in that world. They know what you're talking about, and code sells. So it's an all-in. It's how we stock our trucks. It's how we pair our teams. It's the soft cultural aspects of how we communicate and work together. It's humble, hungry, smart. That's how we hire. That's how we train. It's an all-in achievement. All cylinders go. You're going to have a warehousing team that's delivering materials to the job site. You're going to have materials boxed and ready, jobs estimated ahead of time. Electricians back into the warehouse. Man, they grab, they go, they're out to the job. That's 8 and 10 hour days, but still 2 weeks of paid vacation every year, plus a bonus on your truck performance. So that's the goal there. You have to be able to measure software, and how you input the data has to be able to measure the performance of every truck. The code states in Chapter 9 that short, discontinuous lengths of conduit designed solely for supporting and protecting wire. There's no fill limitation on that. So I'm going to shove a 10.3 Romex in here. Well, let me show you what we just pulled out of there. Hold that down. Check this out. This thing is chafed all the way up. It was pulled in over a conduit. That's one of the worst spots there. See that? It's pulled in over a 1/2 inch EMT edge where the insulation was probably getting nicked hard. There's another one. There's another one. That is ugly. So there's no protective bushing on the edge. And probably got nicked and then shorted kind of a high resistance short against the edge of the conduit itself. So I don't know if they've been having all kinds of issues with this dryer, or maybe it was never enough to trip the breaker, just sitting there getting hot. Whew! That's why you check stuff. And that's why you communicate the stuff you find like this to your customer, because they need to know they're making the right decision. And this was the right decision. Wire lube it. Shove that 10-3. Has a ground. I want that outside jacket all the way through into the surface mount outlet down there. Offset is not helping us at all. That's where the resistance is coming from. It's not there?
No.
Man, I thought that was going to be it. All right, let's put some more lube in there. We made progress. Ideally, that'd be a 3/4 inch PVC conduit on the exterior wall, but all right, we've got this beautiful GFCI above the sink. It's not being used. It's got an open port. It's got old cloth conductors. It's immediately above the sink. I'm getting rid of it. It's also a non-protected box. There's no enamel or galvanization on this box, and it's on an exterior masonry wall, which is a wet location, so it is going to corrode. It's probably been here a while and it hasn't, so it'll be a little soft on that point. But this goes upstairs. Any chance that this is live, connected to something meaningful like an old alarm system that's maybe 20 years old but still being used? That's what I have to be mindful of. That comes into here, and that's that. Okay, I'm gonna look outside for that, and then I'll be able to cut all that out of the way and clean this up. That'll be satisfying to the customer, right? They walk in here, it looked horrible before, it looks great now, and part of that looking great is the fact that this rat's nest is out of there. Unused datacom has to be removed by code, like not provisional, not spare, but like antiquated, unused. And so that's what that is. Be nice to be able to just spend 10 minutes, snip it out of here, and put a cherry on the top. Yeah, let's get that knocked out, then you can do those. Okay. I'll keep lacing and landing. Wait for Tim to get back before we finish off that dryer. Check this out. This is a well-labeled bus. Most buses do not have information, but this has got the circuit number all the way down. Every position is a plug-on neutral. And then here, it's optional backfed breaker position with a hold-down spot right there. So it's beautiful. Like, they thought of so many more details, from the number 2 terminals up here to the number of positions you can land grounds and neutrals, to all of these hold downs here. See that? This isn't done yet. What we're going to do is, there are these punch outs on the back, and there's aluminum foil on the tape, so that's not just open to the outside, but you can slip a zip tie through there and cinch up your panel and make it beautiful. Like, it goes on and on. There's so much innovation here that's real basic, but noteworthy. That's gonna work. Ah, beautiful. Okay. I had to pull out a rigid nipple here and use an offset nipple there, so we get our surge protector right where we wanted it, despite this rigid conduit. And that surge protector needs to go right here, closest to the incoming power. Every additional inch of wire length, which would correlate to placement of the surge protector, or bus length, dramatically changes its protection of the panel. Dramatically changes. So you don't put your surge protector at the end of the panel. Get it, move things around, get it up here if at all possible. Okay, this usually I set my stuff inside the bottom of the panel, but this panel is 54 inches, top to bottom. It's a monster, and so setting stuff in the bottom of the panel is too low. You have to bend over to get it, like go get it. Putting stuff on top of the panel is too high. You can't see it, and so it's awkward in that regard. It's definitely a different kind of beast. Let's do this. Let's get that out of there. Let's go ahead and put a counter twist in these. Okay, they're gonna spin freely here after all. There it is. It's not look good. Right there. Surge protector's going in here again, closest position to the main, and then shortest leads possible. Give them 1 twist per inch. If there's any kind of distance on there, that will help reduce inductance. And that's caused by AC circuits. DC circuits don't get inductance. Am I wrong about that? And so these will be nice short leads. This surge protector, we have good, better, best in surge protection. I recommend you do too. a $2,000 unit that's spec pro, and the thing is boss. You get what you pay for. This FS 140, 140 bucks, and then the standard breaker plug-in stuff, jobby, 375. And that helps customers with decision making. Oftentimes, having the power of choice, they like that. As opposed to, ooh, is there just that, you know, they ask that, right? Oh, is there just that one option? Do you have anything else? Sounds a bit high. Sounds a bit, you know, or we've been through this before and we really would like the good one. We had one at our last house, don't recall what it was, but they start telling a story. You get people talking, just be quiet and listen. They start telling a story, and there's usually a lot of value in those stories. On two-pole breaker, watch, I'm going to show you here. Two-pole Leviton breaker. There are two neutral terminals. However, there's one N printed right there. That, if you've got a device that requires a neutral, particularly plug-on neutral, that's the neutral to use. If I plugged in right here, this two-pole breaker has got no connection up here. That neutral would not be engaged, and you can see that. There are some metal tabs there, but nothing here. So if you relocated the neutral up there, that surge device would not have a neutral. So this is a real easy rock in. Oh, it's tight. See if I'm all the way in there. Feels like I am. There it is. Rock in, rock out. There it is. It's got torque ratings on the side, temperature, strip length, standard stuff you'd expect. Line is here, load is there, it's marked. I like that. It looks good. You do something like this and customers start talking about it. There it is. Found enough room on the conduit. We're gonna punch it, drill it, put it right there. Been plenty of times I haven't succeeded the first time. Should become more of a planner, I guess. See if that does it. Okay. Rigid conduits are tough to get back in the panels. It's really time consuming. Okay. There it is. Oh man, so this is just one of the disappointing things of encountering a project like this. You've got all this teach each end running through a conduit, right? And you've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6 hots, one of which is unused. 4 grounds, really? And there's no pairing. All these were landed on single pole breakers. None of them, they all should have been identified. 1 hot, or maybe 2 hots if it's a multi-wire branch circuit, to 1 neutral. Put a little zip tie, put a piece of tape, couple 3 wraps of tape on that, that would identify it. But now, we'll land it, it'll all work as long as we don't have additive loading by putting 2 conductors that are sharing a neutral on the same phase. Get into that later. But the ticket is, we don't know which goes with which. If at some point you come back here and put an AFCI breaker in thinking that it was paired intentionally, it's not. There's, 1 in 5 chance it's going to be right. The first one's going to be right. 1 in 4 chance the next one's going to be right. Or however that math works. It's no bueno. So we might need to do some tracing, figure that out. Tone out conductors. I'm thinking about what our responsibility is here, how to execute on that. Maybe it's a change order. Maybe it's a change order. What we could do, Bruce, we could do this. This is what we're going to do. We're going to turn the breaker on one at a time and energize these things. And then we're going to check with all the neutrals landed and only 1 hot on. We're going to check with the amp meter on the neutrals and see which one's drawing. And then we're going to move that one, match it to that hot, and we'll know that's a circuit. And we're going to go through that exercise 1 at a time. So the only thing that's not going to work about that is if the other end isn't pulling the load. We'll have to go find the circuit, which we will when we label it anyways. So we'll get things labeled up, we'll find the circuit, and we'll move the neutrals to match. That'll be the fastest way using an amp meter. All right, I'm gonna walk outside and plug in the meter. It's off at the main, just like it should be. Turn on, insert the meter, come down, turn on the main, trace these circuits, identify where they go, get the neutrals re-landed down here, and then finish terminating this side here. Make sure those Stabs are clean, didn't pick anything up. Start at the bottom. Get that in and then look away. Yep, no arcing, that's good. You know that song by Pitbull? Fireball. Well, it's not today, so we're good. That's it. We're energized inside. It's all live parts inside are covered up, so we can leave it energized while we finish terminating. And at some point, we'll start flipping stuff on, putting the breakers in, and we'll get some lights downstairs, start recharging our batteries. All right, let's get these in. 1, 2. Turning this on. Look away. Like to retain your face in the event of an arc flash.
We don't have any 40s.
Right, it's not,
Is somebody already
actually that
playing
much.
that or something?
Huh,
I don't see any 40s in here, and they're all 30s. We need 5.
that's funny.
5 30s.
Oh, we have basement lights. Look at that. Okay, so those are on, but I'm actually gonna do one at a time. So that's basement lights. Let's start with that one. We're gonna get the neutral figured out. So here it is. If it ain't Klein, it ain't mine. Charles, you know who I'm talking to. That's a good one. Okay, so I'm gonna take that one conductor, 2.01. So now I'm looking for which one of these neutrals has 2.01. There it is. So that's the corresponding neutral. So now I'm going to turn third to bottom off and relocate this neutral, cut to length right there. Third to bottom. That, my friends, is that. We'll just rinse and repeat through that process, and we'll have this dialed in, and then I will identify which neutral. Well, I mean, the structure of the panel does that pretty well, but I'm going to go ahead and probably put a little zip tie on that. And the neutral is on top on this side, so third to bottom neutral goes there. It's still so crowded, it's hard to get to my tools here. So little lateral space. Now remember, panel's live. These stabs are hot. 0.35. I'm glad each one of these is coming on with a little load. It really helps. 0.35, 0.37, that's it. Just check here for grins and giggles. Nothing. Okay. Turn that back off. Relocate. So before I do that, second to bottom. That's second to bottom. Before I do that, let's do one more thing, because I need to figure out which ones are these. Are the 2 poles? So I'm going to turn this on, and I know that's it. But I need to figure out which other one. See if any of these others share. No, nothing came on. Okay, now see if anything else shares. We know these have their, so it's going to be one of those. So it's that one. And that is where it's landed. So is it this one? Nope. Or this one? Nope. So not either of those. This one is second to bottom. No. There's one.
Anchor.
Nope.
Is it? Reverse.
Interesting.
Yeah.
So this one's second to bottom.
Concrete.
It's not, I mean, they're all off. This one. So effectively, there are 2 that don't seem to have a neutral right now. Of course, with the breakers in the off position. Watching out for the bus. And pop this down here. So it's possible it picks up a neutral elsewhere. But I'm going to label them question mark because we've got to come back to those. And the house is aged with some original wiring. It's not unlikely that hot and neutral are not run together, and they've got a like you need to rewire the house kind of issue that's not going to be resolved at the panel. So we're going to be circumspect. I'm going to label those. And this one, the other mystery is here. Why do those hots not seem to have neutrals? I got to investigate Well, this is the critical path to completion is right here in front of the panel, so I'm going to get these things marked so Tim can get them pre-stripped, so that'll facilitate terminations. Oh, we got some crisscross applesauce going on there. It's going to be fun. How many electricians does it take to pull in 27 bajillion wires? Rigging the last cable into the panel, and it's tight. I'll probably break the cheap zip tie. Hoping I don't slip off and crash my elbow on this concrete sill to my right. Just maintain the focus. My shoulders are tired. I'd like to go home. It's about 6:55. I like my family. I'm a baby. What can I say? It's 5.5?
55.5, okay.
By 14.25.
Okay, 55.5.
That's one of the funny things about Leviton is the cover comes separately, and so we don't have a cover for this panel today. We'll be coming back. We had a couple breaker shortages. Usually these things are sitting on the shelf, but somebody placed a massive order, according to our warehouse team, the day before, and they were like out. So this stuff was coming not from Indy, like it usually does, but out of city or state, one or the other. We're gonna start flipping things on. Here goes the main, boop. And then the things I'm sure of, we're gonna flip here. We've got a little bit of testing and troubleshooting to do, some weird
On the three.
some weird things. That one should be good. So this is an odd one. That neutral situation. These are. Do we ever do those question marks? I want to identify those circuits that need some troubleshooting. Trip position is still in the middle, just like standard breakers. That's good. That one's got a question mark. Basement lights. All right, now let's make sure we've got all the vital stuff. I'm gonna go check fridges, freezers, alarm systems, sump pump, furnace, air conditioner. Family's not home until Sunday night, and if there's something not working, I want it to be like workbench outlet in the basement, right? But we do have some oddities in the wiring that are giving me pause for thought. I would love to trace it out and do some diligence there, see what their appetite is for another change order. All right, so I'm just gonna set that probe in there as my ground. That's picking up 122, and I'm just gonna run down and make sure everything is as expected. Tim was torquing down terminals after I landed them. It's good to have a double check, but then triple check is useful too, because I found one wire that was just kind of stuffed in there, jammed in there, and was not tightened down even after I went over it, Tim went over it. So that good old-fashioned little tug test. Just make sure everything's performing. I don't know if it's got battery back. That's good. 124. Convection. Water softener outlet. That is off. You kind of think, oh, there's light. Okay. We're almost done. We've got some issues identified with some question marks here, where we're gonna have to trace out the associated circuiting on a time and material basis. On our dime, finish labeling the panel. We did process over $600 in change orders. Heroic effort. It's 8:05 p.m. My advice to you is subscribe to Electric Pro Academy for real skills to make real money.